Hey everyone, I'm super excited to be here, and today we're going to present Lightship Visual Positioning System, and hopefully giving you some tips how to get started with our platform and enabling you guys to merge the virtual real world a little better. So we're first going to give some introduction about what Lightship VPS is. Then we'll talk about the two main APIs needed to interact with Lightship VPS. And then we'll end the discussion talking about the development flow and some other things that developers need to know when building with Niantic. So what is Lightship VPS? Lightship VPS is Niantic's technology that allows users to know exactly where they are in the world. Niantic has been and keeps building 3D maps of the world. Right now, those 3D maps are centered at specific locations that we called VPS-enabled Wayspots. At these locations, users can use Lightship VPS to localize by pointing their device at specific localization targets. So we can localize. How does this happen a little more in detail? So there are two main components. There's the ARDK-enabled client and Niantic Cloud. The device, powered by ARDK, sends images and GPS readings to the cloud. The cloud will take these images and GPS and process them in relation to our 3D real-world maps. Using the latest and best computer vision technology, we send back information to the client, and the client then is able to know exactly where it is in the world, and is set to be localized. So now we're localized. How do we place virtual objects in the real world? So Niantic offers this interface called Wayspot Anchors. A Wayspot Anchor basically represents a specific point in the real world. Users can create Wayspot Anchors, can persist them through time, and they can also share them. We share them through very lightweight payload that Anvith will later explain in the API. So how does this look a little more vividly? So we have a first user in the first video placing virtual objects, in this case plants, near a Wayspot. Then, at another time of the day, in another air station, using another device, another user comes to the same location and is able to localize. And they find the same virtual object being rendered at the exact same location that the first user placed them. This is the magic of persistence. So I've been using this word Wayspots a lot. Let me clarify what that means. Wayspots is just a unique or notable publicly accessible real-world location. Niantic takes notes of many Wayspots around the world, and a subset of those Wayspots are VPS-activated Wayspots. Sometimes, however, developers don't really want to go outside to a specific public location to try out the Lightship VPS to prototype. So Niantic allows developers to create private VPS locations for development. This is exclusively for development. When we talk about development flow, we'll talk a little bit more about how these private VPS locations are created and how can we make use of them. So now that we have the basic concepts, let's tie everything together. We have an app called the AR Voyage that showcases our Lightship VPS. You see a map here. Each purple dot here is a Wayspot. Each Wayspot has certain information associated with it, including a name, a GPS location, and an image. So in this video, we go to this specific Wayspot, and as we get close to it, we get a hint image that allows us to know where to point our phone. Then we localize, and once we're localized, we're ready to go. We can start placing virtual objects. In this case, again, some type of flower. Each specific virtual object is tied to one Wayspot. That's an important detail. Then we close the app. Another time, someone opens the app. They are around the same location. They see the Wayspot in the map. They walk to it. And then they localize. And here the magic happens again. They're able to see the virtual objects placed exactly where they were left. Thus, the objects persisted. So we've seen this flow, and we can identify two parts. One of them is going to the Wayspot, knowing where Wayspots are. And the second one is using the Wayspot Anchor API to place virtual objects. Let me talk a little bit about the first part, that is, how do we find these Wayspots? We offer to developers this thing called the Coverage API. The VPS Coverage API is basically just a way for developers to guide the users to successful localization. So if we go back to that example that we had of AR Voyage, we see that there's a map view with specific points in the map that are Wayspots. This is very helpful to guide users to the specific points in the real world. Then we also see that there is information about these Wayspots that make the user know exactly what they need to be looking at in order to have an immersive experience. So now that we understand a little bit more of how AR Voyage does this, let's see how developers can do the same in their own apps. The VPS Coverage API is a two-step process. The first one is about getting information about the coverage areas around you. The developer can input a query radius and a query location, and the API returns the coverage areas. The coverage areas are polygons in a map, and they have certain characteristics. The first one you'll notice is localizability. Some of our Wayspots have production-grade localizability, meaning at those spots in the world, our VPS works really, really well. Some other Wayspots are, some other coverage areas are more experimental, meaning our 3D maps in those areas are not quite where we want them to be, but we'll get there. Second important thing to notice is within a coverage area, we have localization targets. Right now, one Wayspot has one localization target. Localization targets are basically the specific location in the world that the user needs to point their phone in order to have a very successful localization. So the second step of the Coverage API is getting more information about these localization targets. So where this is a specific coverage area, we want to know, in this example, more information about the Swiss flag tree and this other Wayspot. We use the Coverage API and request information about this specific localization targets. And we get three main important pieces of information. First of all, its name. What is it? Second of all, its approximate GPS coordinate, meaning where they are in a 2D map. And third, and most importantly, a hint image. The hint image here is key, because as a visual positioning system, we need to be pointing at the right things in order to localize. These two steps can be mapped back into our Lightship ARDK calls. The first one, request coverage areas, that takes the inputs that I described before. And the second one, the request localization targets, that you can get more information about each specific target to guide your users to a successful experience. Tying this together, the VPS Coverage API guides users to a successful localization. It's important to use this API well, so we can provide users with a seamless experience that guides them to an immersive AR experience. So this is the first piece of the puzzle. How do we get from somewhere in the city to an area that we can use Lightship VPS? The second piece of the puzzle is about Wayspot Anchors API, the way that we place the specific virtual objects in the real world. And my friend Anvith will talk a little more about this.
Thank you, Ian. Hello, everyone. My name is Anvith, and I'm a software engineer with Niantic. As Ian mentioned, I'm here to talk to you about the Wayspot Anchor API in Lightship ARDK. So now that we have our user at this VPS-activated location, it's time to turn on the camera and get into AR. So the first step, as Ian mentioned, is to get the device to recognize where it is with respect to the world, what we call localization. In order to do this, there's 3 lines of code that you need. The first, you need to create a Wayspot Anchor configuration, which has some parameters that developers can tune if they would choose, or they could just use the default configuration. The second, we need to know the approximate GPS location of the user. So it's OK if the GPS is not accurate. It could be off like by 20 meters, 30 meters. That's the point of VPS. We take this coarse GPS location and give you centimeter level accuracy in 6 degrees of freedom. The third is to create the Wayspot Anchor service. When this Wayspot Anchor service object is created, you pass in the config and the location information, or the location service, and the system starts to localize. Now, using the hint image, the user can pan the camera around, and you get a callback through the Wayspot Anchor service, letting you know when the user has localized. Now, once the user localizes, there's 2 things they can do. They can either add content to the real world, or they can go look and discover content that other people or developers have placed in the real world. So first, let's look at the create flow. The first step is to take a Unity game object and figure out the local pose of that object so that you can then persist that object in the real world. So to do this, you could use a hit test with a plane or any other technique that you choose to get the pose of that object. And then using the Wayspot Anchor service that we created previously, it's a very simple call to create a Wayspot Anchor. You provide it a callback, which returns to you the anchor that was created, and you provided the local pose. We're not going to go over the async API here, but ARDK also supports the async flow, where if you choose, you could use the async flow. The second part of the process is to receive this anchor that you have requested. So in the callback, you now get a array of Wayspot anchors. So if you created just one, like we did here, you get back just one Wayspot anchor. Now let's look at what to do with this Wayspot anchor. If you want to persist this Wayspot anchor across AR sessions and devices, you need to save this somewhere. So you could either save it on device, if you only want that user to come back and find that content, or you could upload this payload to your server and then distribute it to other users who want to find this piece of content. The Wayspot anchor that you received in the previous callback has a payload which comes with a very handy serialized call. This serializes to about 200 bytes of data. You can just treat it as bytes or a string. You then write custom code to save this data. Again, you can host it on a database, or you can save it locally on device. Now, once this anchor has been saved and you have a set of users who've dropped content in the real world, you now want other users to discover this content. And that's where the restoration flow comes in. So the first step here is to deserialize, or to load the payload that you saved previously and deserialize it. So again, the loading needs to be handled by the developer. So you load it back maybe from player preferences in Unity or from a database. And then you call the deserialize call, which gives you back a Wayspot anchor. You take this Wayspot anchor payload and you register it again with the Wayspot anchor service. So when you call restore Wayspot anchors, you're given back a Wayspot anchor. So now we went over 2 ways in which a developer can obtain a Wayspot anchor. Either you create a new one or you restore an existing one. So now that you have this Wayspot anchor object, the next step is rendering it in the AR session. So to help you do this, every Wayspot anchor object comes with a tracking state updated call that gives you the position and rotation of that Wayspot anchor in your local coordinate space. So the cool thing about this is ARKit and ARCore have arbitrary local spaces across AR sessions, but this anchor will sit in the exact same position in the real world. So even though the position and rotation is going to be arbitrary on every device, when you render it in the real world, it's in the exact same spot across devices and sessions. So now that we know how to build an AR experience using Lightship VPS, let's talk about development workflow and how you would iterate through this process of building a persistent AR experience. So the very first thing I want to call out is that both the VPS Coverage API and the Wayspot Anchor API are fully supported in the ARDK mock system. So what this means is you can test your entire gameplay end-to-end in Unity. So in this example, you can see I have a scene set up. I click on play. It then boots up a virtual scene. It also mocks a localization. At this point, I can click to place Wayspot Anchors. I can then hit save, which saves it locally to my laptop, stop that session, and then restart it at a later time. So now this is simulating a user revisiting that location. And if you hit load, once you localize, again, it's a mock localization, it loads and deserializes the payload, and it shows up in the same place like you would expect on a mobile device. So this should help with rapid iteration without having to build to device each time. Now, the second part of this is once you're done developing, fix most of your bugs, you do want to try it on a mobile device before shipping it to users. So as Ian mentioned, one option is to drive down to the closest Wayspot or walk down to one if you have one in your neighborhood, but that's not ideal, especially if you're still in your development stage. So we give you the option to bring VPS to you. What this means is you can scan your desk, your backyard, or in this case, your vacuum. So over here, I'm using the Niantic Wayfarer app. This is, again, available. You can go to lightship.dev to get access to it. You take a 30-second to 1-minute video recording of the location that you want to enable, and then you upload that location to Niantic. Once you upload the location, you can see below a screen grab from the lightship.dev portal. So if you go to your account dashboard on lightship.dev, you can monitor the status of this particular scan. So it will say processing initially, and within 4 hours, you should see a green box that says processed. At this stage, what that means is this location is VPS activated. So you can now localize with this location, and it should behave exactly like a public Wayspot, which is VPS activated. So this allows you to test everything at home. So in the second video now, you can see me going back to this VPS activated location once it's been processed, localizing with it, and once I've localized, I can place these cubes, which represent Wayspot anchors, and now persist content in my living room. One important thing to note here is these scans are private to you. What that means is in Niantic Wayfarer, you log in with your lightship.dev account. Once you log in with your Lightship account, this scan is tagged to you and your API keys. So if you want to localize with this location and utilize this location, the app that is localizing needs to have your API keys set. So your private space is not shared with other developers. The second thing to note here is this private space will also not show up in the Coverage API. So we don't want people walking up to your house and trying to localize. For further resources, feel free to go on to lightship.dev. We have code templates. We have guided learning. So there's videos which goes through most of the APIs we spoke about today. There's also text tutorials, step-by-step, that you can follow along to build your very first Lightship VPS experience. Secondly, we used clips from AR Voyage a lot during this talk. That's already available on the App Store and Play Store. So feel free to download it and get a sense of how VPS works around you. Cool. That was everything we had for today. And yep, we'll open the floor up now for questions. Thank you.
So thank you both. OK, it's not working. So thank you both. Come up to the mic if you have any questions. We have about 5 minutes, so time for 2 to 3 questions.
Yes, sir. I'm Satyan from Thailand. We do this in Thailand, like game like Ready Player One, and we found the problem of GPS of mobile phone cannot like you said, 20 meters, 10 meters far away from the location, and this software can be used only in US or anywhere in the world. This is the first question. The second, when we do localization, we can do location. How big we can do localization, and we gonna make like multiplayer game like 200, 300 people in like around 400 square meters in front of the biggest store in Thailand. Is this software can be applied for our games? Thank you. This is amazing. This is amazing. Yeah.
Thank you for the questions. So in terms of coverage, we right now have 6 launch cities where we have a high density of coverage. It is not US only. So we have Seattle, Los Angeles in the Bay Area in the US. We have London in Europe. We also have Tokyo, where this is available today. And we're expanding. We're going to keep adding new cities. Again, on the lightship.dev portal, you'll see our latest coverage area and the cities that we support. For your second question, as of today, I don't know if we have Thailand activated, but it's definitely on the cards, as in we are planning to expand our coverage.
And if you go into the forums and the Discord and you tell people that you want to build something, you can make a case for allocation and we can start thinking about those places.
Yeah, and we're following our developers. So as Ian said, let us know where you want VPS. For the second question, I think that's a little bit more involved. We can definitely chat after the talk. Right now, VPS Wayspots, it's a 5-meter snow globe. We are planning to expand it and also connect the dots. Multiplayer is definitely possible. Like these payloads, as I said, they're 200 bytes. You can send them to as many players as you want. Anybody can localize as long as they have the anchor payload. But we can chat after this. Cool.
Hi, thanks for the talk. So I think you kind of answered my first question, but it was about the usual scope of a Wayspot. So because I saw there was like the flag tree or some sort of monument. So from what you said, I understand it's more of like a point and 5 meters around that. So it's not really that you're scanning a whole city square and that's the Wayspot, right? It's more like an object somewhere inside that. And just the second question. So the Wayspot Anchors is just bytes essentially. So it's not really readable in some sort of like latitude, longitude, rotation kind of style, like I don't know, the GeoPost standard or something like this. It's just like some proprietary information that you're using, right?
For the second question, yes. The Wayspot Anchor hides a lot of computer vision information inside that we use internally to link to our 3D maps. You can just think about it as like a blob. For the first question, you can localize, and then you can use the phone tracking system to move around, like where you localized. The more you move away from the Wayspot, and if your tracking system is bad for some reason, the less likely you'll be to have a very accurate experience, But you can always localize and move away using the tracking system.
So, for example, if I was creating a private Wayspot in my house, would I be actually scanning more or less a single object, like you showed the vacuum cleaner, or would I be walking around the whole house and that would be this one private Wayspot?
So the scanning process, you would want to recreate what the user is going to see. So it's one focal point in a 5-meter area.
Okay.
And again, we can discuss offline. We just have 2 minutes left. So I'd want to.
Well, yeah, pretty much. It was similar to my question in terms of indoor use. For example, a museum setting, right? I was envisioning based on what we are developing, like an experience that is shared with other users within the same area, but pretty much my questions were answered.
Okay, just to add to private locations, like completely private locations right now are meant for development and iteration only. However, if this museum or mall is publicly accessible, you can log on again to lightship.dev and request that that particular museum or mall or notable unique place be added to our dictionary of Wayspots and then activated for VPS. So all of this is detailed on lightship.dev, and we have a process where you can submit locations that are not available today and request them to be enabled.
Thank you.
My question, oops, too loud, kind of goes to that. You only have 6 locations right now with high density. I'm in Miami and there's no density. So if I start using the Wayfarer app to start to create these spots, what is the typical time period for me to do a scan? Because now it's just me doing one scan, not a bunch of developers in Miami doing these scans. Once I do a scan on Wayfarer, submitting to you, what's the typical time period to actually make it a way spot where any developer can do it, where my app can localize against that?
Again, great question. So there's 2 steps to this. If that Wayspot doesn't exist at all, we have a process now where you can add a Wayspot. The process for that is already defined, and it's about 2 days or 48 hours, 2 business days to get that added, and then you can open Wayfarer and contribute scans to it. For the second step, we're still defining our process in terms of how you get from there to VPS being available at that Wayspot. But I do also want to mention here that like you're not alone in the sense that Pokemon Go and Ingress players are contributing to this map as well. So even if you don't have other developers in your area, if you have players of Pokemon Go, know that they're helping build this map as well.
Thanks.
Time for one more? Or?
So thank you, everyone.
So Ian and I, Ian and I will be here. We'll hang around for a little bit. So you can catch us outside the hall if you have further questions.
Thank you so much.
Thank you.